Hello, today we'll be doing today's daily lead code challenge question, that is search in a 2D matrix. And the question states that write an efficient algorithm that searches for a value target in an m cross n integer matrix, which is called matrix. The matrix has the following property: integers in row are sorted from left to right, and the first integer of each row is greater than the last integer of the previous row. That means the whole row will be sorted. That means this thing will be sorted, as well as this element would be smaller than this element right here. So as you can see, this property also holds as per given in the question. So how about going to the solution directly? So first of all, a brute force way would be to make a search in the entire matrix and just return true or false, right? This is a very brute approach that must have come to your mind. So what is a better way to actually do it? So I could say something like, I know that the whole row is sorted, right? So we can utilize this property right here, which is given to us. And how we are going to utilize it? So first of all, we can start from the ending column right here and the starting row. Okay, so what I'm doing is I'm starting from right here. So let's say the target is 3. Okay, so what do we need to do? I know my target is less than 7, right? So what I'll do is I'll move to the left column always whenever my target is smaller. If my target is greater, what I'll do, I'll move downwards in my matrix. Okay, these are the two simple moves that you need to do, and just simulate it and you'll get the answer. So what did I just say? That whenever it is smaller, so 7 is greater, right? And the target that we want is smaller. So what I'll do is I'll move on to the previous column. So I'll move from there to this 5. Okay, now again 3 is less than 5, right? So again I'll move to the previous column. So now what I see is that yes, it is equivalent to the target that has been given to us. So we'll just simply return a true. What if my target is something like a 23? Okay, what are we going to do? So let's just see. We're right here. Now as I said, if my target is less than, we move left. If my target is less than, we move where? We move leftwards. If my target is greater, we move downwards, right? These are two things that you just need to do. So what I'll do is, my target is greater. Since my target, what I have said is 23. Okay, so what I'll do is I'll just move downwards, which is towards 20. Again, that is greater, right? 23 is greater than 20. So again I'll move downwards. Now I see 23 is less than 60, right? So what I'll do, I'll move leftwards. Move left. Again move a left. Again move a left, and you just found your answer. Now let's say if I do not find an answer, what we'll do, we'll just simply go out of bounds, and whenever we go out of bounds, we just return a false, right? So this is pretty much the intuition behind this simple code, which I'll be just going you through. So this is the code right here. I've initialized the row and column from the size of the matrix, and what I've done is I'm standing where? At the 0th row and the last column, right? This is the last column, that is the third column, whenever I'm taking a zero based indexing. So this is what I've done. I've just simply written ing and initialized it. After that, what I've done is there is a condition check. If both are in the bounds, that means I is less than equals to row. So what do I mean by that? I mean that whenever I said if my number is greater, what was I doing? I was going downwards, right? I was going downwards. Let's say if something happens and we do not find my index and we go out of bounds, what do? We just return a false. So this is what this while loop is taking care of in the first place right here. That if the element is equals to target, just return a true. Otherwise, just see. If my element is less than the target, what was I saying? I need to go downwards. Why? Because my target is greater. When my target is greater, something like 23, what did I say? You go down, right? You go down. And if my target is smaller, what did I say? We just go leftwards, right? We go left. We go left. This is what I and J are doing. So J is just going left, and what is I doing? I is just going down. So this is the code for the n plus m. So what is the time complexity? It will not be nothing but row plus column, right? But there is an efficient way to do it in logarithmic time also. So I'll be explaining to you the approach that came to my mind first, which is of time complexity. The time complexity will be O of the number of rows, that is n, and log n. So this is what first came to my mind, that is n plus log n approach. Okay, so I'll be explaining you how that is working. So I've written this in Java, and the code is pretty similar. If you want me, I'll just write it in C++ also. The code is exactly similar. Instead of just boolean, you just have to write bull in C++. That is it. Okay. So what is this binary search approach doing? Whatever I'm saying, just listen carefully and you'll understand it pretty easily, because it is very simple. So my target was what? 3, right? So let's take a target something like a 34, that it is better to understand. The target is 34. What do I do? I just go on to the first row, right? And what do I know? If the array elements are sorted, right? And what are the elements right here? The matrix elements. I know it is sorted, so we can perform a binary search very easily. So I'll go here and I'll see if this guy is within the range. That means if 1 is less than or equals to 34, is it? Yes, it is. But is 7 less than or equal, is 7 greater than 34? No, right? So I will not check in this row. Now I come to this second row. I know that I need 34, but is 34 less than 20? Obviously not, so it cannot exist in this row also. Now, is 34 less than 60? Yes, it is. So we'll make a binary search on this row right here. Okay. So we'll just do a binary search in this row right here, and we'll just find it that yes, it is present there, and we'll just return a true. If we do not find, we'll just simply break out of the loop at the end of the day and just return a false. So this is the binary search code that I'll be explaining now. So what I've done here is I've just said that okay, so this part is doing what? This part, this for loop is just iterating over the matrix. Okay, whatever the matrix is, I'm just going on to all the rows and checking if my array element can be sorry, the target element can be present in this row or this row or this row, right? If it is present, do a binary search, and if that binary search returns a true, just return a true. And how is this binary search working? That is a very simple binary search. Nothing, just go on to the matrix element and just see if it is present or not. And this binary search is the very basic binary search where we need to find an element. And yeah, this is it for this one. I'll just run this and show it to you. This works fine. Okay, and this will run when you submit it, and also gets accepted if you submit it. And for the C++ viewers, if you want it, what you need to do is just change this boolean to bull. Okay, and that will work. Got it? This is nothing, very simple code. Okay, and yeah, this is it for this video. If you did understand the solution and the code, so like and subscribe. Thank you.